Good morning, everybody. I just want to firstly say thank you so much for all the effort you have already been putting into these sessions. It is great to see all of your work on Class Dojo and Google Classroom, and I've been trying my hardest to go through everything and make sure that I fed back to you as best as I can. So today's session is going to look a little bit different. You have been becoming frustrated with the problems that I've posed, and I thought long and hard about this. And I don't think it's because you haven't got the maths in your brain. I think it's because you need a strategy to problem solve. So today's session is going to focus solely on that. We are going to be learning a strategy to solve problems. Hopefully you're going to find it incredibly useful and something that you can then go on to apply to any problems that you encounter. Okay, let's go. So I'm going to use my laptop to help me explain the 4-step approach I take to solving problems. It starts by visualising it. And what I mean here is, can you visualise the mathematics in the real world? So I've used this example from a Power Maths book, and you can see the children on a playground and a teacher asking them to stand in 2 equal lines, please. Now, initially, you may not know what to calculate. So what I want you to start by doing is visualising them standing in these 2 equal lines. This may be easy to you because it's familiar. It's something that we see at the end of break times, the end of lunch times. It's something that we do when we're lining up in PE as well, when we're creating teams. So it is something that is more familiar. But there are times when the mathematics is not easily visualised in the real world because it's not familiar to us. So what I want you to try and do at this point is, if there's not a picture, try and draw a quick sketch to make sense of what the problem is looking like. Next, it helps to represent it mathematically. For this particular problem, I have chosen 10 frames and part whole model, but you may choose to use number lines or bar models, whatever you feel is most appropriate for the given problem. Now, the reason I like to add in this stage is because this helps us talk about the structure of the mathematics. What I mean here is, for example, as we have modelled on this part whole model, we can see groups being made. Now, we know when we are using the grouping structure, we are dividing. We are dividing into equal groups. So it highlights the calculation that we need to undergo. Which leads me very nicely onto my next stage, which is calculate it. Here, hopefully all the hard work has been done. You should just now have to calculate it, crunch the numbers essentially, which is what we know many children are very, very good at. It's usually knowing what to calculate that is the issue. So at this point, I put a little useful reminder that your visual representation or your visual model that you've just drawn should actually show you what to calculate. It is just simply the dividing part now that we need to do, using multiplication facts that are known and also using our knowledge of remainders. Once we have calculated it, many people stop there, but that doesn't always provide the solution to the problem. So the final stage that I like to draw on is solve it. And what I mean here is, using our evaluated glasses, what does each part of your calculation represent? So you actually go back to the calculation that you have just gone through, and you tell me, what does the 29 represent in this? What does the dividing 2 represent? And what does the 14 represent? So in this particular problem, we had 29 children. We were putting them into 2 equal groups, 2 equal lines. And this shows me that there were 14 in each line, but there was 1 person left that did not fit into the equal lines. So once I've then made sense of the calculation, I can then choose which part of that provides the solution to the problem that I posed initially. So here you can see my solution. There will be 14 children in each line with 1 child left over. Now, it's very easy at this stage to get caught up with all the numbers that you have crunched and to not know which part you need to actually put in that answer box, which essentially is vital because that is the solution to the problem. So you cannot forget that crucial stage of solve it. Let's have a go at some problems together using this 4-step approach. We're going to start by looking at these problems of the day. Now you'll notice it says 2019 on them. That's because I used them with my year 6s last year. but I thought they were brilliant in challenging them to think mathematically, so I'd like to use them with you too. Let's focus in on the first question. Helen has £400. She spends 1/10 of the money on a new toaster. She spends 1/8 of the amount left on a pair of trousers. Which item costs the most? So without adopting my approach to solving problems, I just want you to have a good go. Have a go and see where it becomes a bit tricky. Hopefully you paused the video at that point and had a good go. Hopefully you've arrived at a solution. If you've become frustrated, I am not surprised. My brain is overloaded with the amount of information in this question already, so I want to start breaking it down. Can you remember what the first step in our approach to solving problems was? It was to visualise it. So I can visualise here that this person, Helen, is in a shop and she's buying a toaster and trousers. Now I think she must be in somewhere like an Asda, a supermarket, because I've not seen many shops that sell toasters and trousers in the same shop. But she's there and she's trying to compare the amount that she spent on each. So she's seeing which one costs the most. I can see that in the real life scenario. So now step 2 was to represent it mathematically. Hopefully you guessed at that point. So over to my working bench with my cup of tea because I'm working hard. So I have started to represent the toaster. Now, using a familiar model, something that we've used with when working with negative numbers is the bar model. And I know that Helen, whole amount that she had was £400. Now, I know that she spent 1/10 on the toaster. So this part of the whole amount is the amount that she spent on the toaster. So therefore, it is the cost of the toaster. So what you've started to see is I've already started to think about this and what it shows. It shows that I'm splitting £400 into 10 equal parts because 10 equal parts make my whole. So I need to use my knowledge of dividing by 10 to know that 400 divided by 10 is, hopefully you've guessed it, 40. Now I need to remember my unit of measure in pounds. So that tells me that each equal part of my whole is £40. So I could go and fill that in. I'm going to do that very, very quickly. So while I'm doing this, think about what this tells me about the amount the toaster is worth, the amount she spent on the toaster. Okay. Hopefully you've had time to think that the toaster must have cost £40. But this information is still really important to me. What does this information show? Hopefully you've recognised that this shows the amount that's left over after she's used £400 to pay for this toaster. So essentially, I mean, I don't know why she would, but if she handed over £400 at the desk, they would have given her this much change. And how much is that in total? Hopefully you can calculate by subtracting this part from the whole amount, and you would recognise that this is the amount left over, and that is £360. Now it's always important to make a note of that. So I've done my calculation at this point. Now I need to then represent the next part, which is my pair of trousers. Now, if we go back to the question, it said she spends 1/8 of the amount left on a pair of trousers. So it does not say that she spent 1/8 of the total amount. So remind myself how much was left over after she had bought the toaster, £360. So that represents my whole amount that I had to spend on a pair of trousers. A very expensive pair of trousers if I'm spending that much. Fortunately, she only spent one part of the whole amount, one of the 8 equal parts. So again, because I've represented it like this, it shows me what I need to calculate. And I can very clearly see that I need to divide 360 into 8 equal parts. So I need to do the calculation, 360 divided by 8. Now, I don't know any known facts that can help me with this calculation, so I'm going to use the method of short division to help me. So I'm going to write my jottings on the side. So I've got £360 that I wish to split into 8 equal parts, or divide into 8 equal parts. If we're thinking about that being 300s, and I've got 300 place value counters, okay, how many groups of 8 can I make from that? I can't make any groups of 8. So what I'm going to do is I'm going to exchange those 300s for 30 tens. So now I have 36 tens. I do apologise for my squeezed together numerals, but here we have 36. So now I can think, well, 36 divided by 8, 36 tens. So if I had 36 counters that were all worth 10 each, how many groups of 8 could I make? If you want to do some jottings down the side for you, 8, 16, 24, whoop, it's hard when you've only got one hand, 32, I know that I can only make 1, 2, 3, 4 groups of 8 successfully. Now, that only used 32 place value counters, but I wanted to use 36. So I've still got 4 counters that are worth 10 each that I haven't used. So I'm going to exchange those, and I'm going to rename them or exchange them for ones. So I now have 41s. So again, I've got 40 counters, all worth 1 unit each, or the units of 1. And I'm trying to make groups of 8. How many groups of 8 can I make? I can make 5. So you should have deduced the answer is £45. Add my unit of measuring. So I can therefore tell you what from that. So as I again write down what I know, think about what this shows. Okay, so hopefully you have shown that a pair of trousers costs £45. Now, this was only the calculation. Remember, the fourth and final stage was to solve it. So I need to go back to the question and explain what each part of my diagram represents. So here I am. It says, if she spent an amount on a toaster and spent an amount on trousers, we can work out which item costs the most. So if we go back, we can say the toaster costs £40, which is this part of the diagram, and the trousers cost £45, this part of the diagram, and can conclude, therefore, that the pair of trousers was more expensive. It cost the most altogether. Let's have a go at the next question. So we've got 3/8 of people watching a play are adults. The rest of the people watching are children. There are 32 more children than adults watching the play. How many people are watching the play in total? Now again, a lot of information that probably overloads your brain. So what I want you to now use is the 4-stage approach to solving problems that we've just used for the other problem. Have a go, pause the video and see how you get on. So hopefully you're back buzzing with excitement because everything fell into place. But if you're not, I'm going to model it for you anyway. So first step is to visualize this. Now we haven't got any visual model here. We can't see what this looks like. So we're gonna have to draw a sketch. And as a great mathematician likes to be, I have been very lazy because the focus is on the mathematics, not on how artistic we can be today. So I've drawn a simple stickman sketch. I have a larger stickman or woman representing the adults and a smaller stickman or woman representing the children. I remember from the question that 3/8 of people watching a play are adults. So what does that tell me about the fraction that are children? I'm just going to add that to my visualization first. And by the way, this is the little theatre that they're watching a performance. Very artistic. So I know that 5/8 are children because 8 equal parts make my whole. And if 3 parts are adults, 5 parts must be children because 8 equal parts make my whole. So then I go on to representing it mathematically. So I know that this model is the amount of people watching the play. I know that 3 of those 8 equal parts are adults. So therefore, the rest must be, hopefully you've got it, the children. And I can write down that that is 5/8. Now I just need to remind myself what I was being asked to do. So there are 32 more children than adults watching the play. So what does that look like on my model? I can see 3 parts are adults and 5 parts are children. So how many more parts are children? Because that's what I need to focus on. I can see 3 parts are adults, so 1, 2, 3 parts are children. These 2 parts must be more. So I'm just going to shade those in so that you can see them there. Now the question told me that there were more children watching the play, and in fact there were 32 more. So that tells me that actually these 2 parts are worth 32. So again, using the method that I've used so many times over this week, how am I going to find out what one of these 2 parts is? Hopefully you're shouting to me, 32 divided by 2 equals something. And hopefully you can see that the answer is 16. Okay, to that calculation. So it means that each of these parts is worth 16. So I'm just going to fill that information in. And as I'm doing that, think about what that tells me now. What does that tell me now? It tells me how many adults in total are watching the play, and it also tells me how many children in total are watching the play. So I'm just going to give you a little bit of time to calculate that, because it says if I go back to solving it, which is the final stage of the problem, how many people are watching the play in total? So I don't just want to calculate the adults, I don't just want to calculate the children. Think about the most efficient way of calculating the whole model. How many people in total? Hopefully you're saying to me 16 times 8, because there are 8 lots of 16 here. 1, 2, 3, 4, 5, 6, 7, 8. So I can do 8 times 6, which is 48. I know that I cannot place my 4 tens in the ones column. They need to be placed here. And then I can do 8 times 1 10, and 8 lots of 1 10 is 8 tens, but I have also got 4 tens hidden away here, so in total that's 12 tens. We know 10 tens is 100, so I know that it is 128. Okay, I'm going to leave that part there for now. Let me know if you'd like one more question and I can pose one for you.